Welcome back to Programming Logic and Design. In this chapter, we're going to talk about the AND logic. All right, what is a compound condition? Compound condition asks multiple questions before an outcome is actually determined. So one type of compound condition is needed when the results of at least two decisions must be true for some action to actually occur. So an AND decision requires that both of two tests evaluates to true and requires a nested decision or a nested if or a cascading if decision. If condition 1, then do if condition 2, and if condition 3, then and only then we do something. That is cascading if. So let me go through this with example. So this is how it sort of looks. If condition and condition, then statement, else if condition and condition, then more statements, else more statements, end if, end if. Now this is a nested if statement, and what we're actually doing is when we've got condition and condition, it's actually two if statements we're combining into one. So let me take you through an example. All right, let's have a look at figure 4.7, the flowchart for the self-earned billing program. We're going to call the self-earned billing program JJ Self-Earned Company, and what we actually do is we are given a basic monthly service of $30. An additional bill is going to be billed to customers who make more than, if you have a look, more than 100 calls and more than 500 minutes. So both of those together will get an additional $20. Okay, so what we're going to do is we're going to start with our declarations. If you have a look at our customer ID, customer made, call minutes, and these are all going to be num, as well as our calls bills. We've got calls, minutes, basic service, and premium. All these three are our named constants. And the 100 calls corresponds to our 100 calls there. 500 will be the minutes. And basic service, which is our basic monthly service, is $30, as well as our premium, which is our additional $20 over here, is our premium. As I said before in previous videos, is that we always start our programs with our housekeeping, and within our housekeeping we output phone payment calculator. This is just basically a nice little heading for our program. We want to have a nice heading so that the user of our program knows what's actually happening in our program. Then we are going to be inputting our first priming read. So where are we getting our priming read from? Where are we getting our programs from? This over here, this section here, our customer ID, calls made, and calls minutes is coming from a notepad or from a text file, a database, whatever. It's coming from an external source. We'll be learning this more in chapter 7. Chapter 7. That is why we have not end of file here. Now the not end of file is saying is when we get to a space or when there is nothing left here, we are going to be exiting our loop and we go straight into our finish module. So let's start our program. So we input customer read, so customer ID, calls made, and calls minutes. So we are working with our first one here. 82760 is now stored into customer ID. 999 is stored into calls made, and 305 is stored into calls minutes. So we go into our not end of file, because we're definitely not end of file here in the beginning. We go into our detailed loop. We start our detailed loop, and our detailed loop says, okay, what are we starting with? We start with customer bill is equal to the basic service. What is our basic service? It is $30. So we are storing $30 into our customer bill. Then we go into our decision here. What's actually happening? Is my calls made, which is in this case 99, is 99 greater than calls, which is 100? No, it's not. So therefore we're going to go through our null case and output the customer ID, the calls made, etc., and call minutes, and then our customer bill will just be $30. Let's input our next one. I'll make him red. So we're going to input the next one here. So we're going to input 79854 into customer ID, calls made, which is 100, into calls made, and 502 into calls minutes. Then we're going to loop up to the top. Customer bill basic service is going to be $30. So we're starting at $30 now again. So in all, what we're actually doing here is we're replacing our customer bill from the first one, which was $30. We're just replacing it with $30. We're overriding whatever was stored into the customer bill. Now, is 100, we're now working with 100. Is 100 calls made greater than calls? No, it's not. So then we're going to go through the null case, print the ID, call customer ID, the calls made, and call minutes, and we're going to output customer bill, which is $30. And then we're going to input our next one. So I'm going to make him blue. So we're going to input 65545, 16047. They're going to be stored into their respective variable. This is going to be $30. Is my calls made 160? Is that greater than calls? Yes, it is. 160 is greater than 100. So therefore, we're going to now ask the next question. We're going to go, is calls minutes, which is 470, is that greater than 500? No, it is not. So therefore, we're going to go through the null case, and we're going to print customer ID, and it's going to remain 30 yet again, and we're going to input the next caller ID. Next caller ID, I'll make him black. Let's erase the next one. 30 is going to remain 30, and calls made greater than 100. Is 180 greater than 100? Yes, it is. And we ask the next question now, is 620 greater than 500? Yes, it is. Now we're going to go $30 plus $10 is going to be stored into customer bill. So customer bill is now going to be $40, and therefore we're going to output $40. We're going to input the next customer ID, calls made, calls minutes, which is blank. It's end of file. And when we get to the question here, we're going to ask the question, are we at the end of file? Yes, we are at the end of file. We're going to exit the loop, we're going to finish, and we're going to output program has ended. Now, if we had to compare it to our pseudocode, here is our declarations, and our declarations is indented under the heading declarations here after start. We have our housekeeping module, which comes next, and that housekeeping module calls on that housekeeping module. If you have a look at our loop here, this loop is a while loop, and while loop has got my detailed loop within my while loop, and then of course finish and stop. Have a look at the indentation. That is how you need to be how it needs to be indented. Alright, let's run through and see the correspondence for our nested if statement. Now, what I mean by nested if statement is that we've got one if here, okay, and here is my one if here. And then we have our next if, and that is nested within my if. See, it's nested just within that box. So this one is nested within. So when I'm asking my question here, which is calls made greater than calls, so if calls made is greater than calls, what is it going to be? So we are asking, that's why when I say we're using a conditional and, we need to ask two separate questions. And if that question is true and that question is true, then we only going to build the premium. So that is only when we're allowed to build the premium, because that's just what the client wanted, and then we only output the bill, the premium there. When nesting decisions, either selection can come first. Now, performance time can be improved by asking questions in the proper order. Now, in an AND decision, first ask the question that is least likely to be true. Right, so which question here is least likely to be true? Is calls made greater than calls least likely to be true to calls minutes greater than minutes? Yes, calls made is greater than calls, because I can actually make one call that will last definitely over 500 minutes. Therefore, the one that's least likely to be true, in other words, calls made to be greater than 100, is least likely to be true. So therefore, if we're going to have if these two both need to be true, in order for us to bill the premium, then ask the one that is least likely to be true. We do this because it eliminates as many instances of the second decision as possible, and it speeds us up processing time. The conditional AND operator asks 2 or more questions in a single comparison. So each Boolean expression must be true for entire expression to evaluate in true. So what we actually want to do is we want to have this condition and this condition in one statement. So we want to actually eliminate this if over here, and the way we do that is with an AND. So what we're going to do is we want to incorporate an AND here, and this condition over here, we're going to add it there. So calls made is greater than minutes. Then we're going to charge the customer bill is greater than premium. So this calls made here, we're going to incorporate it in there with a conditional operator called AND. Just out of interest's sake, in Java, AND is 2 of AND symbols in most other programming languages. To do the testing and whether the expression is going to be true, we use truth tables. And this describes the truth of an entire expression based on the truth of its parts. I need to remind you that the need to consider efficiency when deciding the order in which the Boolean expressions appear in the statement. So truth tables is basically a tool to help you understand the AND operator, which we use in maths and logic. And it looks like this. We're going to ask the first question. If it is true, then we move on to the next question. If the first question is false, we don't even need to ask the second question when we use the conditional operator AND. So if true, y true, then the entire expression will be true. If x is true and y is false, the entire expression will be false because y is false. Same for if x is false and y true, the entire expression will still be false. And if x is false and y is false, of course, the entire expression will be false. So how do we change? Nice and pretty. You'll see that calls made greater than calls and call minutes greater than minutes, then we bill the premium. In the flowchart, we just got the conditional AND over here, which is compounding the first condition and the second condition for our premium. So that's why I say we need a nested if in order for us to use the conditional AND operator. An AND operator achieves the same result as our nested if statement here, but using the AND operator often makes code more concise, as you can see, less prone to error, and it's actually much easier to understand when we have the condition like this. Your AND condition is basically a short circuit evaluation. So expression evaluated only as far as necessary to determine the truth. When I mean by as far as necessary, we're going to ask this question first, calls made greater than calls. If that is true, then we only ask the next question. But if that is false, then we're not even going to ask the next question. We just go straight on with the rest of our program. That is what I mean by the short circuit evaluation. The second decision must be made entirely within the first decision. In order for the second decision to be made, the first decision must be true. In most programming languages, the logical AND is a binary operator. So it requires a complete Boolean expression on both sides. So what it's actually doing is that we are eliminating some possible errors. First thing is that if this is not a nested if, we're going to be asking this question and we're going to be asking that question. Whether this is false, we'll still be asking this question and then we're going to bill. But what happens if this is true and that is true? Then the customer is going to be billed the premium twice. So therefore, if he is sitting at 30 plus 10 and he's at 40, then here we're going to go, okay, whatever customer bill is at that time is 40 plus 10, he's going to be now $50. So he's going to be billed double, and you're going to have a very grumpy client when it's just a logical error. Another error which we get is when you write, let's say you want to find call minutes that are greater than 100 and between 200. If you write it like this, this is a condition. Yes, it's a question we are asking, but here this is not. This is an incorrect asking of the question. You cannot write it like that. How you got to write it is you've got to have a correct condition. That's why I said you've got to have 2 full conditions as if you are writing a nested if. Okay, So you always, when you're writing the AND operator, using the AND operator, remember that you are using a nested if statement. So what we are doing is we're combining this condition with this condition and having the AND as our compound operator. So therefore we have to write call minutes is less than 200. So that is if you want the minutes between 100 and 200. So you're looking for all those call minutes. That's why I say it requires a complete Boolean expression on both sides. I'm just going to carry on with this exercise on exercise 1. Just to recall, number big is 300, number medium is 100, number small is 5, word big elephant, word medium horse, and word small is bug. What we have is number big, which is 300, is greater than number medium, which is 100. And number big, which is 300, is less than number small, which is 5. Okay, so we're going to be asking the question, is number big greater than 100? Yes, it is. Okay, so that is true. And is number big, which is 300, less than number small, which is 5? No, that is false. So together, because remember the conditional and says together the expression, what is going to be my Boolean for the expression together? Well, because we have one false and one true, therefore it is going to be false. What about here? Number big, which is 300, is equal to 30. So remember I told you, because you guys get confused between the assignment statements, rather make this equal equal and this one equal equal. So is number big 300 equal to 30? No, it's not. That is false. Okay, they're not the same. And is number big medium, which is 100, is number medium the same as 100? Yes, it is. But because this expression is false and that expression is true, it still remains false. Please join me in the next video in which I'll be discussing the OR logic.